Good morning, everyone. Good morning. Thank you for Blue Water Cruising Association for hosting this event. The word electronic and electrical are used interchangeably by a lot of people, but they're different. Electrical is simpler, right? It's power, right? There's no computer, there's no nothing. I mean, battery chargers, inverters, yes, but pretty straightforward. Electronics are, for example, a radar, chart plotter, your depth sounder, your AIS. It's basically a computer, right? That's what electronics are, right? Phone is electronics. A phone is not electrical. There's electrical within the phone, but it's a little bit more complicated than just electricity, okay? So for troubleshooting, honestly, you can't troubleshoot something without understanding how it works. Otherwise, it's sort of being blind and leading the way. It's not going to happen. Nothing's going to make sense, and it's so random, you're just going to get frustrated. So that's why yesterday and part of this morning, you've got to spend time caring about how conceptually something works. And if you understand how conceptually it works, your chances of troubleshooting something are much higher. If you don't understand how it works at all, troubleshooting it is going to be so random, you're going to get just frustrated and you're probably going to give up. The only thing is, first thing is understand how it works. And once you understand how it works, then you have a chance of solving it by troubleshooting. The other one too is, if you understand how it works, then what are the part of that solution that could have failed? Because it's not a one thing, right? When we looked at a battery charger yesterday off a generator, how many things power a battery charger from a generator? There's a lot of different things that are part of that process. You can't be random. Logic. You got to start at the beginning, you got to walk down. You can't just start going everywhere. You can't be haphazard. You're going to waste your time. Your time is precious. We talked about this earlier. Generally, it's very rare that a device actually fails. Generally, it's to do with the installation of that device. It's possible, but a lot of times, actually, believe it or not, it's things around it. Okay? So the next one is, well, you've got to start eliminating the obvious. You can bring someone on board if you don't value money. But the first thing would be, is the battery switch turned on? Sounds silly, but pretty common. We get called out all the time, a lot of panic. Someone turned the battery switch on or off. They don't know where the battery switches are. They come back on board, their boat is dead, they think their batteries are dead. And their vacation is ruined. They don't leave on Friday night as they planned. And the only problem is, their mechanic turned off the battery switch off when they were doing the work, and they didn't even know they had one, and they don't know how to turn it on. So I've had, no seriously, it happens all the time. Boaters miss a weekend, miss 9-day trip. They're leaving on a Friday, can't get a hold of someone. And then they come to the boat don't start, they cancel the holiday and they go back, and the only thing that was wrong was the battery switch was off. Simple, but you got to understand that. You know, and that's why you got to care. Because none of us, and I remind this all the time to everyone, none of us have enough summers in our lifetime. I don't care if you have 70 summers left in your lifetime, you have 100, that is not enough time left to enjoy life. Every weekend is precious, everything is precious. And so if you missed a weekend because of the battery switch, that kind of sucks, right? Because your boat was ready, you just didn't understand it. Next is the breaker panel. That is super common. Most people don't even bother looking at their breaker panel. How often am I called in that the fridge doesn't work and the breaker that says fridge on the breaker panel is not on? You laugh, but it happens all the time. They don't look at it. Somebody accidentally touched it. They were doing something else. They turned it off. They never look at it. They don't even know it's there. Again, it's not I'm not saying it's their fault. It's just, you know what? Boats are complicated. And the breaker is off, and now suddenly the fridge is off. You turn the breaker on, the fridge works. It's embarrassing and it's frustrating. Make sure that the breaker, does your appliance have a breaker? And if it does, is it on? The next one too is the branch breaker to the device. So like for example, in my case, on my boat, there's no breaker for radar or AIS. I have a breaker for navigation electronics. Now that's code word for a lot of different things. On my boat, it means chart plotter, radar, AIS, VHF, all these different things. So you have to know what those breakers mean on your boat, because you might see, for example, upper bridge electronics. That breaker's off. That breaker gives you tons of different things, and it's off, and you don't, like my radar and chart plotter don't work. You're not understanding that that's a key word for flybridge electronics means navigation equipment running off of the flybridge. So understanding what breakers do on your boat are going to allow you to troubleshoot a little bit things, and then you can't get as frustrated. And the other thing, it's obvious, but did you actually turn on the device? And it sounds silly, but again, sometimes some devices automatically turn on if they were left on the last time. But if you turn them off and you turn the power back on, they're still in off state. So they have a memory of their state. You turn the power off and they were on. Next time you turn the power on, they're still on. You turn them off before turning the breaker off. You turn the breaker on, they're still in off state. You need to change the state. Press the power button on the electronics to now turn it on. Again, sounds silly, but a lot of electronics actually remember their state. So if it was turned off when it was off, it's going to be off when it's powered. And then if you eliminate the obvious, then you start the journey. And that's where it gets interesting. You start at the beginning. First problem that is most common is there's not enough power or no power at the device. Common one is your chart plotter works when you connect to shore power. It works a little bit when you leave the dock, and when you're sailing, it doesn't work. What's that problem? Is it a problem with the radar or chart plotter, or is it the problem that the batteries are getting low with voltage over time, and that your batteries are either getting weak or the connections were not done well, and it only works on shore power because your batteries are at 13.5 on shore power, and as soon as you disconnect from shore power, you're at 12.6, and then you're sailing, you go down to 12.2, and that delta loss and loss makes that your chart plotting radar stop working in the middle of the Strait of Georgia every single time. Is the radar coincidentally knowing that it's in the middle of the Strait of Georgia? Well, it could happen, but no. It's a voltage drop problem. Voltage drop because maybe the batteries are weak, or maybe because the connection was badly weak, it's badly done, and it doesn't manifest itself when you've got lots of power. Battery voltage has dropped too low. Super popular. Happens all the time with nav lights. How many times have we called out to replace a nav light, and the issue is that the nav light is on the bow of a boat, it's exposed to salt water, it's a very corroded connection, right? Same thing on a mast. I was on a boat just recently, well, not myself, but one of our crew going up a mast, changing a steaming light. Was the steaming light broken? Was the fixture broken? Not at all. It hadn't been installed properly, it leaked, and the connections inside were corroded, and corroded enough that so we cleaned the connections, redid them properly, and the nav light and the fixture were working. By the way, the owner bought both a nav light and a replacement light, because when you send someone up the mast, time is money. So just because of a bad connection, that hardware was already purchased. They already had it on their nav table ready for us because they assumed that it was the light or the fixture. It was neither. It was the connections. Corrosion on the terminal or connector. Oh my God. Welcome to a world of hurt. That is, any connections that are in an inhospitable environment are going to have corrosion on the terminal or the connector. And that's the first place to look. Handoffs of energy through connections are the #1 culprit. And the chance of a broken wire or a broken wire on your boat are 1 in a million. 1 in a million. How does a wire break if it's a flexible wire? Now, solid core wire, oh yeah, of course, no problem. No problem. But a flexible wire that's broken? Now, of course, there's exceptions. I had an owner for example, on his radar arch, had someone install deck lights. And when they installed the deck lights, they drilled a hole, and they hit the wire inside the tubing, and it made their satellite dish not work. They literally drilled a hole right through the coax, of course. Then I always ask, did someone do anything around there? Did anybody do anything? Oh, no, nothing. We did nothing. We just installed lights. I'm like, bingo. Where did they install them? Oh yeah, well, there you go. Sure enough, you pull the cable and you see like a drill mark right through the cable. So that can happen, but if you're not drilling or playing on your boat, what are the chances that you're going to have a wire that's severed? I mean, that's pretty crazy. But a loose connector? That is all the time. Boats vibrate. Vibration causes things to undo themselves. I came on a boat once. They had 12 golf cart batteries, and 8 of the golf cart batteries were not part of the other 4. The connections had all undone themselves. Most of the nuts were not even on top of the battery. They were in the bottom of the battery bank. They had no idea this is about a 60-footer. They had battery problems. Never went to look at the battery. The batteries were not giving them, it was unreasonable battery life. And they were right. Definitely unreasonable. And it's the same thing that, once you do like with wheels or something, you have to go and tighten it up again after 3 months. Right? And if you just hand tighten it, well then welcome to the world of magic. Welcome. So a loose connector, oh, that happens all the time. You got to start it there. Like either the bad crimp or it's a loose connection, right? Now, chafe is real. If you don't support your wire in your boat and your wires are simply loose and you think it's just an aesthetic desire to have things in bundles and they don't move, over time, not the first year, not the second year. Now, if you go offshore, yes. But if you're here in a marina, 10, 20, 30 years of chafing absolutely will cause chafe. I see it all the time. The jacket will actually be rubbed right through. I've seen that on engines. I've seen it all the time. Wires are just running loose. And over time, just enough rubbing causes the jacket to actually wear off. And then eventually you'll have a positive wire chafed. I saw that on a commercial tug once where one of the jackets had rubbed so much on the metal because it was an aluminum boat. They had lost, the damage was like humbling. And it was one of their wires was actually leaking into the hull, but not enough to cause a short, but enough to actually energize their underwater metals. And it was massive amount of damage. And it was because the bundle was not protected from the hull and it was loose. It was chafing. It was a commercial boat, used a lot. This fuse may be hidden problem. I brought that up earlier. That's a world of hurt too. You turn the circuit breaker on, but you don't have power of the appliance because there's a fuse, and the fuse is sort of hidden. I'll remember that, yeah, it's midway in the pedestal because that's the length of wire, and I didn't want to extend the wire, and that's what it was. It happened to be right in the pedestal between the lower helm and the upper helm, and I'll remember next time if it blow that you just give it a little bit of slack and look, sure, you remember that for a while. What about the next owner? I've seen fuses in places that defy all logic. There is no logic. It's actually evil is what it is. And there's nothing wrong with the appliance. Everything's fine. The fuse blew in a place that you can't find it, and then it's a nightmare. So make sure your fuses, if they are there, they're always accessible, okay? And then use a meter to test the entire circuits in sequence. Okay, with that, we're going to kick off and we're going to talk about, first we're going to start with navigation a little bit. This is the way things used to be. This is called NMEA 0183. There's a newer protocol today called NMEA 2000. 90% of us are going to have 0183 on our boats. It's going to take a long time for NMEA 0183 to disappear. And it's complicated, hence why 2000 came up. But look at a display, for example, a multifunctional display like this, and look at the amount of connections that had to happen for that device to work. And all of these are actually, it's absolutely important to remember what is sending what to what. The right polarity, so this is right now sending information to the pilot and it's receiving information to the pilot. This is truly a bidirectional conversation. The pilot sends heading to the chart plotter. The chart plotter sends tracking information, routing information to the autopilot. Same thing with the AIS, right? You could have AIS information going here. You could have not AIS, but different information here going to the AIS. And then you saw this, like this looks a little bit like CTOC, right? Like bus topology from Raymarine. And then you would have that, and then everything would be daisy chained. This doesn't look that bad, but let's be honest. The reason, like in the past, like 5 years ago, the number of VHF radios that would just have 2 wires connected to the chart plotter for GPS position, which is essential for having a 911 feature, the DSC feature on your VHF radio. Like, we're talking about opting out from 911. That takes a lot of courage. You have to have a serious level of confidence in yourself to say that I will never need a 911 in my life. If you opt out into that, like, you're a much stronger man than I am. I can't imagine. 95% of all boats didn't have a VHF connected to their chart plotter or GPS because the 2 wires that needed to be connected were so complicated, because you needed to remember that a talker can only talk to a listener, and a listener vice versa. So you had to remember, I'm a talker, I have to connect to a listener. That one now is a talker and needs to listen, I need to listen to it. So it's literally like you've got to talk on one side, listen on the other, and the other one talks to you. You can't just go talker to talker, listener to listener, because you can't talk to another mouth. I mean, it's impossible. And you can't listen to another ear. So literally people would go talk, talk, listen, listen. They're thinking it's going to work. No, didn't work. And that's if they were connected. Less than 10%, and it's probably closer to 5% of VHF radios were getting a GPS position. So that little DSC function on the radio was disabled. Useless. No value. Everyone was opting out of 911 because it was too complicated. Okay? And so it was very rare to actually see an NMEA network that was fully utilized. And that was sharing information between different pieces of electronics equipment on your boat, so that, for example, you could have AIS coming to your chart plotter, right? Or have maybe your chart plotter also sharing into a laptop, okay? And that's easy. On the big boats, we did a 115 footer. It was a crazy amount of work. And that's what it looks like. It was humbling. Literally every single of those devices we had on that boat. We had multiplexers, gateways, converters, bridges. You had all these different devices, and everything was context driven. A talker talks only to listeners. You can only have multiple amount of listeners. You can't have multiple talkers talking to one listener. Then you've got to have a multiplexer. And this was the world up till recently. Like, we did that boat in 2012, and we built it like this in 2012. So that's not that far. And what happened is, then the world came, and you can't troubleshoot that. This is, you're done. I mean, you're sort of like, tap out. And that's why people didn't like integration, because honestly, you couldn't get it to work. And even if you could, you couldn't troubleshoot it because you needed to have a crazy understanding. And then the world went to this. And now this one, we can help each other with. This is called NMEA 2000. If you've got a navigation equipment that is less than 5, probably even 10 years old, 10 maybe, depends. Garmin for sure. Raymarine has a rename. They just call it CTalk NG. Same, but different. You're going to have what's called a CAN bus here, which is the NMEA 2000 backbone. And then you're going to have a bunch of drops. These are called drops. The power needs to energize this backbone. And then you can have instruments, a chart plotter, another instrument, a fuel sensor, a transducer. And on some boats, like we did a 145, you know, there's like 70, 80 of those drops, right? I mean, it's crazy. But you could have a Celine, a 60-foot Celine. We did a 60-foot Celine. They've got about 40 drops, 50 drops too.
With one backbone?
Yeah, one backbone.
How do you know what you have?
Well, you can actually, believe it or not, if they're all properly wired, you would actually be able to, in one of the displays, like even on your chart plotter, to actually see every single NMEA 2000 device that you have on an NMEA 2000 backbone. Or you can also buy a diagnostic tool, and you can plug it into one of the drops, and you'll see every other device on the backbone.
That'll tell you whether it's a 2000 or
Well, you'll see that actually on a chart plotter will tell you. Like if you've got a chart plotter, you'll actually be able to see in the COM ports, see communication ports, NMEA 2000, and you'll have, literally, they'll actually name you what they are. They'll say fuel sensors, carbon monoxide detectors. They'll actually tell the name of what it is. Like on one big boat, we did another 115. We had 9 tanks, right? Every tank had a fuel level sensor, right? Bilge water, dark, gray, fuels, hydraulic tank, right? All of them were NMEA 2000. This wasn't invented by the marine industry. It's basically, like a lot of things, good ideas come from other places. This was invented by Bosch. It's CAN bus. It's control area network. It's any to any. There's no talker or listener. Everything can talk or listen. And there's no intelligence. You can take one device on, you can take it off, it doesn't matter. It's basically auto learns how to prioritize information. Different items on the backbone have more priority than others. A GPS has more priority than, say, a fuel tank sender. So even if the network is congested, certain things will go through over other things. You don't need to know where your fuel tank level is every second, but you want to know where your position is every second. So they all have, it's a protocol, and they know when it's their time to speak. If they speak too often, and depending on their priority level, they're going to be brought down. You can have NMEA 2000 compasses, chart plotters. Now, NMEA 2000, not to be confused, will not send video signal. What's a video signal? Video signal is sounder image, a radar image. All those things that have a high amount of content cannot go over an NMEA 2000. They're going over an Ethernet backbone. We're going to talk about that in another slide. NMEA 2000 is a limited amount of data. AIS will go on there. You can have depth, but not a fish finder, but depth as a number. And that's why they call this an intelligent transducer. This device actually calculates depth inside the device and outputs depth to the backbone. It's common. We do that on trawlers all the time. We did an 80-footer. We'll do, the bottom, they'll have normal depth fish finder, and then we'll put in a secondary depth sounder, just depth only, just as a backup. We do that a lot. Even some boats, 40-footers, 50-footers, some sailboaters, I did on my boat, you'll have depth as a fish finder and depth as a number. You probably have that on your boat.
From one transducer?
2 transducers. Yeah, you'll want backup. It's backup. No, but they'll do that. It makes sense. Honestly, it's not crazy. There's a lot of gadgets in life. Depth is not a gadget. If you think depth is not important, and I meet owners sometimes that tell me, I don't need depth because the chart has depth. I choose to not engage in a conversation because I don't have the time, but that is an interesting choice. I'll leave that at that. I am not one to believe that. They don't ask me what I think, and so I don't share because, obviously we can't find middle ground on that. But I am a huge believer that depth is not a gimmick. I'm a huge fan of depth. Propulsion, steering, depth, VHF. Lead line. Yeah, lead line. Lead line works, but depth is pretty important. It's up there. It's really up there. So you can buy a transducer now, like an NMEA 2000 transducer that connects into a backbone, and you can have depth at the front of the boat and you can have depth at the back of the boat. Big boats could do that on a sailboat. Depth at the front of the keel, depth at the back of the keel. You can do whatever you want. And they're not expensive. And so again, they're not working with a big chart plotter. You could actually see it directly onto an instrument, right? So a lot of depth sounders, for example, fish finders, you need a big chart plotter to be show that. You're not going to see that on a small. A fish finder is not going to work on a 4-inch, let's say, small instrument. You see depth on that, but you're not going to see a fish finder on a 4-inch instrument. And so if you want to have, for example, on a boat, you want to have some instruments showing depth on here, you're either going to have that on, or you're going to have an intelligent transducer connected to that so that you don't need your big chart plotter to provide a fish finder, which gives you depth to then in turn share that information with the little screen. So we do that all the time on trawlers, like 40 foot, all the time.
I don't see a radar up there.
No, and that's right. Why? Because I said radar is large image. It's video. Can't be up on NMEA 2000. And that is one of the biggest misconceptions there is. People think that NMEA 2000 can do everything. No, it can't. It's a limited amount of bus, right? It has some throughput, but it cannot do a video image. You're not going to have video cameras on NMEA 2000. You're not going to have a radar in NMEA 2000. Your radar doesn't take NMEA 2000. There's no such thing as a radar NMEA 2000 port. You'll do an autopilot. Yes, your chart plotter is going to be connected to it. But again, it's not going to be sharing your chart data is not going to be sharing from one chart plotter to the other chart plotter over NMEA 2000. That's way too much data. That is going to happen over Ethernet. And we're going to talk about that in the next few slides. Limited amount of data goes over NMEA 2000. So when you're troubleshooting this sort of network, and quite honestly, this is not rare, not anymore. What happens is generally is one of these little rings, these little connectors, gets loose through vibration. So you need to know where every single T is on your boat. This is called an NMEA 2000T because it has 3 sides, right? And that little nut there could get loose. And if it gets loose, then you're going to lose the backbone. Half the backbone is going to work. The other half backbone is going to work. But both of 2 halves of your backbone, if they were powered independently, would be working but not talking. Or you might have one that's energized, the other one's not energized, and the other one's dead. Because you see how here this needs power. If that fuse blows or is disconnected, and I get this all the time, my NMEA 2000 doesn't work, I lost it. And honestly, as simple as the circuit breaker labeled NMEA 2000 on the dash is not energized. This is why it's so important as boaters to be curious. You're not curious until you have a problem. The chances of you being able to ride a bike or ski, if you've never skied before, are pretty low. You might have a high level of confidence in yourself, but if you've never practiced and you don't know where things are, when things don't work, it's upsetting. It really is. And then you're depending on people like myself to either help you remotely, if I'm available, or what happens sometimes, some of my technicians get on float planes. This morning, you're going on an airplane. You're going in the middle of nowhere, and you're going to go rescue someone. And that's what you end up doing. And some of those rescues are worth the time to go, and some of them sometimes aren't. And they're simple little things. So understand your boat so that when things do go wrong, you know why. And that circuit breaker here, because you see how you have to have an inline switch or ignition? That inline switch, if it's off, then your intelligent transducer is not going to work, your fuel flow sensors are not going to work, your autopilot's not going to be even energized. All these systems are going to be down and you're going to be driving yourself crazy for just simply a switch on the dash that you didn't know existed. As simple as that. Now, here's the bad news. This looks simple, right? It's pretty simple. The bad news is the MacGyver technician or the MacGyver owner that looks at this and thinks he can do whatever he wants and does not educate themselves. I've seen it even in production boats after the fact, or the manufacturer does normally this, and the owner decided to emphasize strongly to the manufacturer that they should do more. But they're not really competent at that, and so they do it, but they shouldn't do it. And I've seen boats that are worth $250,000, $750,000. I saw a power boat, like a high-end power boat, $700,000 power boat, like it was 35 feet. So you can imagine what kind of power boat that is. It's not size that they bought, it's a lot of gear. And the NMEA 2000 backbone, it took us 3 days to fix it because they just thought it was plug and play. They didn't follow the protocol. There can only be one resistor on one end and another resistor at the other end. You can't have, it needs to be one backbone and then individual drops. I have a YouTube video just on the backbone. You have to follow the code. And most people, remember what I said, nobody likes reading. Thank God for YouTube, at least now people can watch. But without that, you have to follow the code. And if you don't, then welcome into the world of magic. Question?
How many drops can you have on one backbone?
I don't remember. Something like it's 64 or something like that, or it could be 128. There's all these lengths, there's math. I don't remember. But there's a limitation. There's a limitation on the number of drops, the number of cabling. There's apps to actually measure all that. Maretron has a great app. Like, we don't chance it, we'll design it, and we'll actually do a design and then execute, and it's a software, and they'll tell us if there's errors. But yeah, don't take the chance. Everything's simple until you do it. Question in the back? One question is, how essential are the termination resistors on a backbone? Utterly critical. If you don't have them, it won't work. Or it's going to work, it might work sometimes, but it's going to work intermittently. You could actually remove a connection and still have the T there, but have no connection at that point. So, like, oftentimes we'll be running a cable through the boat and we'll have spare T's in different locations. As we're leaving the engine room going up to the flybridge, we might put a T in a few different places so they can add stuff as they go along. Under no circumstances, the question is, can you put a cap at the end of a T right here? A cap here is not protection against moisture or anything. It actually is essential for the communication bus. You can never have more than 2 T's, and the 2 T's have to be at the end of the backbone. No one shall ever put a third T anywhere on a backbone. The backbone has a start and it has an end and nothing else. Correct. Shall never put a resistor or anything on that is a resistor on a T. There are caps if you want, like cheap little caps if you want to protect the pins, but a termination resistor is not a cap. And if you do, welcome to the world of magic. It's 5 wires in that cable. The CAN bus cable has 5 wires, 2 for signaling, 2 for power, and 1 for ground.
So it's proprietary?
Oh yeah, 100% proprietary. 100% proprietary cable, and that's why Raymarine, of course, decided to give it a different name, and they called it CTOC NG. And they changed the pin configurations and the connector configurations to make it more complicated, but it's CTOC NG. It's sort of like me calling English Kinglish. I don't know, just making it up a different word, but I don't change anything. I don't make any difference. It's just I relabel it. It's just to confuse the marketplace. That's all it is. Confuse the marketplace. I mean, it works. I mean, there's a reason to do it, but yeah. So you can talk from CTOC NG to NMEA 2000, you just need a pigtail. It's just a wire. There's not even a box in between. It's just going from one proprietary connector to a non-proprietary connector. It's a marketing decision. It doesn't really make any difference. This is a bigger backbone, right? Again, bunch of T's, a drop for power, and then you can start seeing, like this is NMEA 2000 to USB gateway, larger chart plot, not a chart plotter, larger instrument, solid compass. This is a weather station with a GPS. Like not this one is GPS, but you can buy weather stations. This is a DST 100. This is a smart intelligent transducer. Gives you depth, speed, and temp. And then you can have some, we did a boat about 2 years ago. We digitized the whole boat. So all the circuits on the boat could be turned on from a chart plotter, right? The whole boat was wired like that, like from scratch, the boat, and we did that with C-Zone. So we were doing that. You've seen that. Like, for example, Boston Whaler does that too. They're doing C-Zone. So you can actually turn on every circuit you want on a chart plotter. You can do anything. You don't even have a panel on the boat anymore. The panel, your screens are your panels, right? And you can say, here's a mode. I'm on the mode at anchor. Then a bunch of switches automatically get turned on and off. I'm underway navigating. Bunch of switches get turned on and off. I'm going to bed. Bunch of switches get turned on and off. I'm going to leave the boat for an extended period of time. Bunch of switches get on it. So you have different modes. And you're able to do that via these digital switching modules, which are connected, believe it or not, over NMEA 2000. The point is, when you're doing NMEA 2000 or anything on your boat, first of all, create a schematic. Okay? That's first point. Don't just do it. Like, write it down, because you're going to forget what you did even on your own boat. So make a plan, right? Think about building a house with a plan. That would be sort of crazy, right? The house would not look normal. Nobody's ever built anything that looks pretty or looks pretty impressive without a plan. Like, the plan is the first part. And I even remind this to my own technicians. I'm like, no. Like, we're not going to do anything. You're talking a lot of words. Great. Yeah, sure. Take a picture of your plan. Send it to me I want to see it. Let's look at a plan and let's build to a plan. And when you're doing NMEA 2000, if you have one, start creating a diagram. A little bit like a wiring diagram. We wrote an article in Pacific Yachting, I think about a year ago, about if you don't have a wiring diagram on your boat, create one, right? Be curious. Because again, when you're going to need to troubleshoot your boat, it's going to be really helpful if you've got a wiring diagram. You can do a lot of magic and a lot of troubleshooting with a wiring diagram. If everything is just buried and you don't know where things are, it makes it quasi-impossible. Well, unless you have lots of time or money, but it becomes very frustrating. So even on my own boat, that I love my boat, I have a wiring diagram of where all my T's are, what they do, where are they on the boat. So if I ever want to troubleshoot, I know where all the devices are. And if you don't have one, it's a great rainy day project. Question is, can you start integrating 0183 to 2000, right? Like and absolutely. There are gateways that are 0183 to 2000, and you can start having a hybrid system. You don't have to go all in. You can start creating an NMEA 2000 backbone, have a legacy system, and have the legacy and the new sort of talk over what are called 0183 to 2000. And we do that all the time, even on like crazy navigation systems where someone's dropping $100,000. Believe it or not, some gear is still staying. That doesn't change everything. You know, the autopilot might be 0183 and we're not going to change it, and we're going to have a gateway from that to NMEA 2000. Because at one point you can't do it all. And on a normal boat, the same thing. We might keep the instruments CTOC, which is not it's not even 0183. We might take the instruments Raymarine CTOC, leave them there, and put a CTOC to NMEA 2000 gateway, or CTOC NG, and then CTOC NG to NMEA 2000, and we'll put a new navigation suite and leave the instruments there. So it's not an all or nothing. You can integrate. Okay. Now this is an example of, look at, they've got blue is for NMEA 2000. Instruments, chart plotters, satellite, that's XM radio, VHF, that's NMEA 2000. And then look at the red. The red here is Ethernet. So they've got an Ethernet cable. And notice there's a little one there too. That's hard to see, but it's important. Little red here. So the chart plotter, the sounder box right here, the radar are connected over Ethernet. Okay? And that's how really modern navigation systems are done. You've got always two protocols. One Ethernet, NMEA 2000 or NMEA 083, but you have both. Because you can't share a radar image or a sounder image on NMEA 2000. There's just too much data. Okay? Question, a chart plotter would have NMEA 2000 and Ethernet and NMEA 083. Some of them actually will have all three. They'll be able to integrate NMEA 2000, 0183, and Ethernet on the same port. On not same port, but the back of the device. That's why there's so many ports at the back of those things. And some of them will actually even take like coax for video cameras. Question is, Ethernet wire is a solid wire. No, marine grade Ethernet wire that you would buy from the manufacturer because they have proprietary ends to actually lock them in place. They're still RJ45s, right? Those wires are actually, they're Ethernet wires, not solid. Right? They're going to be like, well, I mean, they're tiny, but they're not big solid. They're going to be marine grade Ethernet wires on those RJ45s. But now they're tiny, the wires. They're super flexible. Ethernet wire, you could almost coil in something this big, right? This is another example of the same picture. You see this switch over here? This switch is doing Ethernet to a radar, to a sounder, to a chart plotter, Switch like at home, right? It's Ethernet. And then you have an NMEA 2000 bus doing an instrument, an autopilot, a VHF, an AIS transponder, NMEA 2000. And it's also talking to a chart plotter and another chart plotter. And then you have basically a panel that is powering each device, right? The radar, the chart plotters, the switch, the sounder, and also the backbone. This is a very typical Nav system. Not hard, just pretty vanilla. That's how they work. NMEA 2000, Ethernet, and then power everywhere. And then it gets more complicated when you have legacy systems that are 0183. Question is, seems redundant to have two cabling to do one thing. There's going to be, there's a new protocol called OneNet. I think that's the name. It's in the works right now. Redundancy, though, is a good thing. You know, personally, I don't know if I'm ever going to ditch my NMEA 2000. I'm going to do it unwillingly. I like depth, certain information to be standalone. I don't want to have all my eggs in one basket. Remember, this is navigation. This is not your loss. You can't watch CNN anymore and your day's really off because your football's not coming in. Right? You're talking, I want everything to be on one cable in one system, so much so that I'm willing to learn depth, AIS, GPS, everything about everything. And I want to be blind. I want so much simplicity. Geeks are going to love that. Honestly, people that are geeky are going to love that. I'm a little cautious. I like to have two separation. And on the big boats, guess how many backbones I do? I don't do one backbone. I do multiple backbones. And on the big boats, do I do even one backbone? I have a big backbone, two of them, and then I have redundant backbones right beside, right? Just in case. Because remember, this is not a gimmick. A lot of us are going further afield to places that we would never go if we didn't have charts or if we didn't have depth. And without that, there's a lot of places that we wouldn't go. There's places that are pretty tricky. They're pretty damn tricky. And if you didn't have a chart plotter, and i.e. a lot of us only have a chart plotter, there's a lot of places on Vancouver Island. Like I spent all the summer on the outside of Vancouver Island this summer, and let me tell you, it is pepper sprayed. It's like an evil joke. It's like rocks everywhere. And if you don't know where they are, you're going down. There's no other way around it. It's not predictable. You're not only going to hit shore, and you're going to sink. There are rocks where you would never expect them. And I don't think that a lot of people are going to be comfortable putting everything, all their eggs in one basket. It's going to happen, but it's going to be an interesting adoption rate. I think there's going to be there's going to be some people that are going to sort of hold on for a long time. Okay, question? Yeah, so the question is, if you have a chart plotter, or there's a note that you also are in a lot of countries legally responsible to have paper charts. And that's true, and on my boat I do. I had paper charts before I bought my chart plotters, and I have a lot of paper charts. But there's also a reality that we get comfortable with chart plotters. And I think if one day somebody removed my chart plotter on my boat and I was in a really tricky place, like in the Browns or outside of Vancouver Island, it would be scary. Honestly, it wouldn't be the same. I wouldn't have been there in the first place if I didn't have a chart plotter. And I have charts, but there's something to be said about a radar overlay, a chart plotter, a good depth sounder. And if I didn't have any of that and I just had a compass, I probably would not do a lot of things that I do right now. I would not be gunk-holing in a lot of the areas I go. I just wouldn't. I wouldn't be comfortable. I would risk tolerance. I would be like, you know what? Let's just keep it in sort of familiar waters where I know most of the things and there's not a lot of things to worry about. Question? Redundancy. How can you achieve redundancy? Like you buy, for example, I have a Navionics app on my iPhone. Great idea. I have it on my iPad. You want redundancy. Absolutely. But iPhones and iPads are great, absolutely, but then you can't do radar overlay on an iPad right now. So you can do radar on an iPad, but you can't do radar overlay on an iPad. So that's why I think it's good to have both. Radar overlay gives a high level of positional accuracy. Radar doesn't lie. Radar is only the truth. They only see, it's there or not there. There's nothing, and that's why all the big ships and commercial operators run their boats by nothing else than radar. Radar is the truth. Everything else is sort of trying to make it easier for ourselves. This is an example of a typical Raymarine network. This was brought in about 2005, 2007. So you see that on a lot of boats. You got NMEA 0183, you got CTOC. They both had those ports. CTOC HS is Ethernet, going to a switch, going to a sounder, other network displays. The radar effectively here is coming up at the top, but it's not really true. It's actually going at the back of this switch. You had remote cameras going in, so you could have coax feeds. You could do a remote monitor. And then you had a GPS, which was either NMEA 0183 or CTOC. But that's basically what it looked like. That was 2005. And things haven't changed that much from there. You still have the network. You might not have CTOC. You'll have 0183. You'll have NMEA 2000, and you'll also be able to bring either now IP cameras or coax cameras. But things are pretty much the same. This is an example of a modern equivalent. Not that modern. This is probably 3 years old now, 4 years old. But you can actually see there's no switch here because this device has like 2 or 3 Ethernet ports. It's a switch in itself. So you got a radar connected to it, another display. You've got Wi-Fi going to a tablet. You've got cameras, VHF going off NMEA 2000. And then you've got your instruments, your control head for your autopilot. You've got an AIS. And even your autopilot, the reactor is actually working on NMEA 2000 for communication. And then you've got a smart transducer or a transducer plugged into the back of this one because this one is called XSV. So this one is not smart. It is actually a traditional transducer. And that transducer goes on a transducer port. So nowadays, a lot of depth fish finder functionalities are actually built into the screens. You can actually have a transducer plug directly into the back of the screen. And so this is not just Raymarine, Garmin, Furuno, Simrad, B&G, Lowrance. They're all doing this. And so now instead of having, before we had chartplotter and depth sounder, like a black box, now the black box and the display are built in together. But you have to buy it like that. You have to know that you need it. And so that's the differentiating for Raymarine, for example. They'll either have it as XS or XSV. The V means side view. You know, the good news about electronics and the bad news about electronics is that there's a lot of choice and there's a lot of choice. It's good or bad, right? It goes either way. This is a Furuno. We were on a 90-footer just recently, and this is not unusual, you know? But the trick is to draw it out. You know, even if I have a technician living on a boat for 4 weeks, 8 weeks, 12 weeks, and it's their life, that's it. That's all they get to know is that boat. Eventually, it gets even too much information to remember while you're working on the boat, right? It's too big. You got to work from a plan. And it's a really good habit to work from a plan. It's really good. You can always go back to that. It's like the habit of taking notes, right? And now look at this. I mean, you're actually seeing all these Ethernets everywhere. Junction box between all these NMEA 2000s. Look at all these instruments that are NMEA 2000. All this stuff, an Ethernet hub that is Ethernet. Radar, sat compass. So the only hope in hell to troubleshoot your nav system is to have a diagram for it. To be honest, if you don't have one and you're not a pro, you're in a world of hurt. You're just in a world of hurt. So I can't emphasize enough for people to be curious and to start creating a diagram for their nav system now when things are working, than waiting for things not to be working. And it's one thing if you're having an electronic problem at the dock. It's easy, you can call in a tech. But if you are away from the dock and it's happening in a faraway place, and you can't even, there's no road that even leads there, and you can only get there by float plane, and you've got to come back days of journey to get back into civilization where someone can even come and meet you, you'll never regret having that diagram, because any technician can help you troubleshoot something if they know what they're looking at. Question is, do I know of any apps that make it easy to do diagrams? No, I use professionally Visio or AutoCAD. Some of my technicians use AutoCAD because they know it. I use Visio because it's easier, but that's not easy. I say you can even do it on a piece of paper. You know, honestly, don't find reasons not to do a diagram. It's like not going to the gym. Here's the list of the million reasons why I'm not going to do any exercise this week, and we're all really good at selling it to ourselves. And how about finding the only reason why you should go, right? Like, there is no reason not to have a diagram. Just put it on a piece of paper, pencil, and honestly make it doesn't have to be pretty. Just start by putting pen on paper, pencil, something, and over time add to it, and then at least you're not going to forget it, because you're even going to forget the things you know about your boat. I do as an owner, and I never thought that would happen. It's like forgetting something about my child. It's like, how do I not know everything that's ever happened? I love her. And yet over time, I'm like, what did I do? And I'm like, oh, thank God I got a notebook. And I go back, I'm like, oh, I totally forgot about that. It's right here. Question is, if I have manuals, is that a good replacement or sufficient for knowing how things work? And the answer is no. Because honestly, the devils are in the details. Everything's easy in a manual, by the way. If you've ever worked with anything technical, the manufacturer makes everything sound so easy. Everything always works. The technician, whoever installed it, found out a lot of problems on the install, and they're going to have junction boxes in certain places. There's going to be things hidden in other places. There's gateways they're not going to talk about. It's the devils are in the details. And a manual is not sufficient. It's good to troubleshoot an individual item, absolutely. Like, I have this thick of binders on my boat for every single piece of electronic gear and gear on my boat. I have literally, it's like takes this amount of space. Like this deep, it's crazy, of every single physical piece of equipment that's installed on my boat. But that is not a replacement for how you ended up installing it, especially when things are networked. That would be my advice. But hey, our boat, each our way, right? It's just an opinion.